In this video, we're going to talk about the fundamentals of probability. So there are three types of probabilities we're going to look at: theoretical, empirical, and subjective. We're going to go ahead and start with theoretical because it's going to take us a little bit longer. And we're going to use an example to kind of start the thinking about theoretical probability. So let's say you have three coins that you're going to toss and record whether or not you get heads or tails. You're going to have a quarter, a dime, and a nickel. All right, so that's what this first example shows. And they want us to do a tree diagram to explain all the possible outcomes that we could have for this. Now, they choose a tree diagram to kind of start this because it's like a technique you should have seen prior in elementary school or maybe middle school. But I'm not very good at tree diagrams, so I'm just going to admit that right off the bat. Okay, so here we go. I'm going to do my best. So first thing, we're going to toss the quarter. So we're going to look at outcomes for flipping the quarter. Okay, so we have two possible outcomes: heads or tails. Now I'm going to pause here and just say, I can draw a straight line just fine. This particular laptop does not let me draw diagonals very neatly. Like no matter how steady my hand is, it doesn't matter. It comes out squiggly because of the way the computer does it. So even though it looks like I can't draw a straight line, it's actually the laptop. I feel very self-conscious about that for some reason. Okay, let's then say if we get heads or tails for quarters, that would be the same case for dimes, right? So if we flip the dime, we either get heads or tails, but then it could be for each possibility for quarters. So we can get heads or tails. And then same down here. Oops. We can get heads. Well, that one wasn't too bad. Or tails. And then for the nickel, same thing. That's actually EL, not LE. Heads or tails. Heads, tails, heads, tails, heads, tails, and there we go. Okay, so here's how we actually list all the possible outcomes. So we kind of follow the path, as it were, to list each outcome. So on the top path, in other words, if I got heads for quarters and then heads for dimes and then heads for nickels, that would be one possible outcome, getting heads, heads, heads. Another possible outcome here, I'm going to try to erase the highlight, is if we went, heads for quarters, heads for dime, but tails for nickels. See how we're kind of following each little path. So this would be heads, heads, tails. Okay, one more time. This time we go heads, but this time for dimes, we go to tails, and then we have two possibilities. We could either get heads, so that would be heads, tails, heads, or we could have gone tails, which would give us heads, tails, tails. I hope you understand how that works. Try to list the next four, maybe pause the video, list the next four, see if you get it correctly. I'm going to go ahead and list it. So now we'd be switching to tails for quarters. So all of these outcomes are going to start with tails, okay? And then we're going to do heads for dimes, heads for nickels. Oops, sorry, tails, heads, heads. Or we could have gone tails for the nickel. So tails, heads, tails. Or we could go tails, tails, heads. And then last would be tails, tails. Oops, tails. And there you go. All the possible outcomes. Okay, so the tree diagram kind of just shows you all the outcomes. And again, I show this because it's something you're supposed to have seen previously, but I'm not going to ask you to do this because, as you can see, it's difficult for me to even do. But yeah, we're not gonna, we're just using it to help us go through the next part of here. Okay, so the next question asks, part B, oops, sorry, asks, can you think of a way to find all the number of outcomes? So how many outcomes did we end up with? Well, if I count them off, I have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So one way to have found that without actually listing all of them would be to multiply each outcome for the each coin. So quarters has two possible outcomes, right? Heads or tails. And then dimes has two possible outcomes of heads or tails. And nickels also has two possible outcomes of heads or tails. And if we take those and multiply them, 2 times 2 times 2, that gives us the 8 outcomes that we have listed. So I could figure out how many outcomes I'm going to have, and then I could just list them all without doing the tree diagram just to find all the combinations. So what is the probability of getting 3 heads? Well, since there's 8 possible outcomes, you're looking for how many times you would get 3 heads out of 8. And there's only one way that happens. That's the first way, right? Where you get heads on quarters, heads on dimes, heads on tails. And there's no other combination where we have 3 heads. So this is actually a probability of 1 out of 8. Now, this one's different though. What would be the probability of getting exactly 1 head? Okay. Now, in that case, we actually have a few possibilities. So I come up here and I see that right here, I have quarters, it was heads, and the other 2 were tails. This one works, right? In that case, dimes was heads, and the other 2 were tails. And then this one, that one had nickels heads, the other 2 tails. So 3 out of 8. That's the probability. Okay. So the idea behind probability is we're looking at how many ways something can happen out of the total possible outcomes. Okay. Which is why it was useful to see how many outcomes there were and then to see what type of outcomes there were so we could explore the probability. That is theoretical probability. Okay, now another way to kind of look at probability is to use what's called a probability model. In this way, we rather than have this kind of diagram or the list out of all the possibilities, we kind of sum it up into a table with each probability. So we indicate the possibility of the number of heads, which in this case, you could have 3 heads, 2 heads, 1 head, or no heads. So I would list that out as 0 heads, 1 head, 2 head, 3 head. All right. Now I happen to find already what the probability of 3 heads were. That was 1/8. And we found the probability that you would get 1 head, exactly 1 head, and that was 3 out of 8. Okay, so then 0 heads, the probability for 0 heads, if I come up here, meaning all tails, well, that would be 1 out of 8 again. And then 2 heads, so we'd be looking for all the possibilities where, here, I'm going to try to erase those highlights. See, sweet. 2 heads would be, okay, this one would count 2 heads, 2 heads, 2 heads. So again, 3 out of 8. So this table sums up all the possibilities without the list of possibilities. And then we can use that information to ask some questions. So first thing they say, what is the probability of getting 1 or 2 heads? So either could work. You could get 1 head or you could get 2 heads. Now, how I could write that, by the way, the notation we like to use for probability looks kind of similar to old-fashioned notation you might remember from algebra. We use P for probability, and then we indicate what we're trying to find the probability of. In this particular case, we're trying to find the probability that you would get 1 head, okay? And then when you're saying or, that means that is another possibility, another option, and that ends up being plus the probability that you would get 2 heads. So the probability you get 1 head plus the probability you get 2 heads is going to be 3/8 plus 3/8, which comes out to 6/8. Now, You will always reduce a fraction if you can, okay? And 6/8 can be reduced. You could divide top and bottom by 2, and that would give you 3/4 as a final answer, okay? So whenever you're working on fractions, you will always reduce them. Now, we hadn't had to do any reducing before, so I didn't bring it up prior, but that's how you would do that. Okay. Let's just answer the next question. I'm not going to worry so much about the notation using the P of probability notation. What is the probability of not getting 2 heads? So basically everything else, we could get the probability of 0 heads, the probability of 1 head, the probability of 3 heads. So not 2 heads. So that would end up being, you could get 0 heads, which is 1/8, 1 head, which would be 3/8, and then 3 heads, which is 1/8. And if we add those together, that comes out to 5/8. I don't know why it's kind of shifting down for some reason while I'm writing. There we go. And that doesn't reduce, 5/8 doesn't reduce, so that's the final answer. Just if you did want to see the probability notation, this would have been considered the probability of 0 plus the probability of 1 plus the probability of 3. In other words, anything but the probability of getting 2. All right, because they said they don't want to have 2. All right, what is the probability of getting fewer than 2 heads? So less than 2 heads, meaning you could get 1 head or you could get 0 heads. Well, probability of 0 heads would be 1/8, plus the probability of 1 head is 3/8. That comes out to 4/8. Okay, that does reduce. Divide top and bottom by 4 and get 1/2. Okay, now another, what is the probability of getting at least 1 head? Meaning we see at least 1 head pop up. And in this case, that means that 2 heads could pop up, that'd be allowed, and 3 heads could pop up, that would be allowed. So we'd be finding the probability of 1, 2, and 3. So 3/8, 2/8, sorry, 3/8 again, 3/8, 3/8, 1/8. Just to write the probabilities for these, we are finding the probability of 1 head, 2 head, 3 head. Okay, that comes out to 7/8. And since I did it on the other two, I might as well go ahead and do it on part F here. So probability of getting fewer than 2 heads, that was the probability of 0 heads or 1 head. That's where we got that. Okay, so just so we kind of see that notation, and we can answer questions just referring to the table above to kind of do that. All right. Okay, empirical probability is based on observations or an experiment. For example, 15% of the parts sampled were found to be defective, which means that there is a 15% chance a randomly selected part will be defective. So in other words, since we don't know when a machine is producing something, how many of them might come out defective, we'd actually have to sample it. We'd have to collect data. And that's what empirical probability does. It uses data. So this uses data. And this phrase, relative frequency, we saw when we did contingency tables. I'm sorry, not contingency tables. When did we see that? I think, oh, maybe this is the first time we're seeing it. No, yes. No, we saw it in chapter 3. Wow, sorry guys. Saw that in chapter 3 when we did bar graphs and histograms. So relative frequency was finding the percentage, and that was based on data. So we'd look at the percent of the data. So that's why they use both phrases, empirical probability and relative frequency are referring to the same thing because it's based on data. Okay, the next type of probability, subjective probability, is based on intuition, experience, or feeling. And I know you're like, okay, is that real? Well, the answer is kind of yes. All right. It's the idea of, instinctually probabilities based on your own experience. or feelings or intuition. So in this case, an example would be, what is the chance you're going to go to a party on Friday? Okay. Depending on who you're talking about, that's going to depend, right? Maybe you love parties. Maybe you're really social. And maybe the party is being thrown by your best friend. So, of course, you're going to go. All right. Maybe you are antisocial and introverted, and the chance that you're going to leave your house to go to a party is very low. Okay. Right. You get the idea. The odds are going to change based on who you're talking about, based on who's throwing the party, right? Like it's all based on the subjective issues that you personally are dealing with. All right. Okay. The other thing that we kind of have seen probability discussed is in the phrase odds, in particular for like betting. Okay. Odds, though, are often misunderstood. So I'm just going to spend a little time kind of explaining how odds work, and then we'll just look at a couple examples of it. So when a team is given odds of winning at 4-7, what that means is the 4 represents wins. So this is representing, wow, that's a sad looking arrow here. I'm actually going to zoom in a little so I can write it a little smaller. There we go. That is the wins. And then 7 represents losses. So 4 wins, 7 losses. So this isn't saying the probability is 4/7, actually. Okay. The probability that they're actually giving to win is based on the idea that they could have 4 wins. If they have 4 wins, they have 7 losses. So really, really what they're saying is that if there are games being played, that's a total of 11 games. And out of 11 games, they are expected to win 4 of them. So the probability of winning is 4 out of 11. And then they do ask what's the probability that they'll lose? Well, based on these odds, 7 out of 11. Okay. So the other phrase, so this was the odds of winning, is where they are doing the odds of losing. So these 2 phrases right here, odds on or odds against, are really saying the odds of losing. So when they say the odds of winning, the first number they gave associated to the wins. Okay. For odds of losing, the first number given is associated to losing. Okay. So looking at this example, the odds on My Little Pony are given 8-11. So because they use the phrase odds on, they're talking about the odds of losing. So the first number they give, 8, is they're talking about a loss right here. Let me write that in red because it's kind of close. So that's a loss. Oops. And then 1 would be a win. So based on what we just talked about above, that means they're technically talking about 9 games, or races in this case. So the probability that they would win is actually 1 out of 9. And the probability that they would lose is 8 out of 9. Okay, that question actually isn't asking about that. They're talking about what betting is going to look like. So if the 8-1 odds means that for every $1 you bet, you'll get $8 if you win. So if you bet $10, how much are you going to win? Well, I mean, it's the idea that when you bet $1, you win $8 if as long as they win. So if you bet $1, that leads to a win of $8. So if you bet $10, that means you would win $80. All right, but that's how odds work. It's actually not giving a probability. It's not the odds that they're going to win is 1/8. The odds that they actually are going to win is 1/9. It's actually lower than it lists. Like above, when it says the odds of winning are 4-7, it's not 4/7. It's actually 4/11. That's less than 50% chance of winning. Okay. So that's what odds mean. All right. And I will go ahead and look at combining probabilities in the next video.